Show by the principle of mathematical induction that for all n belonging to the set of natural numbers n, 10 raised to the power of 2n minus 1 plus 1 is divisible by 11. So here, in this particular problem, we are given an expression 10 raised to the power of 2n minus 1 added to 1. So we need to show that this particular expression is always divisible by 11 regardless of any natural number that we choose. Okay, let us begin. So how shall we proceed? So our first task was going to be converting this into a statement that 10 raised to the power of 2n minus 1 plus 1 is divisible by 11. So what we'll do, we're going to consider Pn, which is going to represent a statement. So let Pn be the statement. Let Pn be the statement. And this statement is going to be given by statement given by, here let us consider P of n such that we have 10 raised to the power of 2n minus 1 added to 1. We're saying that this particular expression is divisible by, it's divisible by 11. Okay, so this is a mathematical statement. So we're going to name this as statement number 1. Now, in order to prove that this statement is always true, regardless of what natural number n that we choose, what we'll do, we are going to first verify that if it is true for the first natural number 1 or not. So for n equals to 1, what we get is P of 1. So our statement is now going to become 10 raised to the power of 2 multiplied to 1 minus 1 added to 1. What is this value? So we have 10 raised to the power of 2 minus 1, which is simply 10. So 10 added to 1, that's 11. Yes, 11 is divisible by 11. That's a fact, which means that our statement, this is telling us that the statement P of n is true if we choose n to be equals to 1. So for n equals to 1, the statement is coming out to be true. So this is the first step. Now in the next step, what we'll do, we're going to assume that let P of m, so here we are choosing another natural number m, let P of m be true. P of m be true, where we are choosing m to be some other natural number, right? Now, this simply means, this implies that P of m, now we have to rewrite our statement. So we are now saying that 10 raised to the power of 2m minus 1 plus 1, this number, this expression is divisible by 11. Okay, so we're going to name this as statement number 2. Fine, so this is divisible by 11. Now using this, we have to show, we need to verify the fact that P of m plus 1 is true. P of m plus 1 is also true. So why we're choosing P of m plus 1? That means if P of m, where m is some natural number, is true, we'll check whether if the next consecutive natural number to that of m, which is m plus 1, if it makes that statement true or not. If it makes that statement true, we can say that it's going to be true for all natural number. Fine. Now, in essence, what we have to do, we have to show that P of m plus 1, this is going to be the statement that we'll need to verify, the 10 raised to the power of 2. Now, in place of m, we're going to replace with m plus 1 minus 1 added to 1. So this expression is also divisible by 11. So this is what we need to verify. Okay, let's call it statement number 3. Okay, now how do we verify this? So what we'll do, we'll take the help of statement number 2. Now from statement number 2, since we have already assumed that the expression 10 raised to the power of 2 times m minus 1 added to 1, that this particular expression is divisible by 11. So what we are going to do, we're going to express it as 11 times some constant lambda, where we are saying that this lambda is a natural number. So it belongs to the set of natural number. And now we will be using statement number 3. Now from statement number 3, let's take only the expression 10 raised to the power of 2 times m plus 1 minus 1 plus 1. So we're going to rewrite this expression. So this is going to be 10 raised to the power of 2 times m plus 2 minus 1 added to 1. Now here, using the law of exponents, we can rewrite the first term as 10 raised to the power of 2 times m minus 1 multiplied to 10 squared added to 1. The reason why we are writing in this particular fashion, because we'll be taking the help of this expression 10 raised to the power of 2m minus 1 plus 1 equals 11m. So what we will do here, so 10 squared, that's simply 100. So we have 100 multiplied to 10 raised to the power of 2m minus 1 added to 1. Now we have 100 multiplied to, so in place of 10 raised to the power of 2m minus 1, we can replace it with 11m minus 1 added to 1. Fine. So that means we now have 100 multiplied to 11m minus 100 added to 1. Fine. So that gives us 100 times 11 lambda, and negative 100 plus 1, so that's negative 99. So from these two terms, we can pull out 11 as the common factor. So that's going to give us 11 times 100 lambda minus 9. Now we have already considered lambda to be some natural number, then 100 times lambda minus 9 is also going to be a natural number. Now what we'll do, we are going to replace it with beta, where we are considering that 100 times lambda minus 9, that's equals to beta, where beta belongs to the set of natural number. So we considered 10 raised to the power of, so we have the expression 2 times m plus 1 minus 1, 2 multiplied to m plus 1 minus 1 added to 1, and we showed that this is equals to 11 times beta. That means this simply tells us that 10 raised to the power of 2 times m plus 1 minus 1 added to 1. So this expression is divisible by 11. Divisible by 11. Now that we have shown that it's divisible by 11, that automatically tells us that the statement that we consider p of m plus 1, so this is a true statement. Now if this is a true statement, now we can generalize this. Now we can generalize this and say that p of n is true. This is a true statement for all values of n belonging to the set of natural numbers n. Yes, so we have successfully verified that 10 raised to the power of 2n minus 1 plus 1, this expression is divisible by 11 by using the principle of mathematical induction.